And Kevin Culp back at you from Supermicro, continuing our podcast on Super Cloud Developer Console. I am the PM head of Cloud Management Solutions here at Supermicro, bringing you this podcast on navigating around the Super Cloud Developer Console, or formerly SDX. In the previous videos, we focused on a couple of things. We showed you how to create an LDAP user to import it. We're going to use that LDAP user to authenticate when we log in to our control plane, where our Kubernetes compute are here. And we also showed you on setting up the storage pool or storage class within our environment. This is a place where these container images are going to be stored from a pool perspective, and we showed you that in the previous video how to do that. And we also talked in the previous videos about setting flavors and prepping the environment based on pre-flight so you'll be successful to be able to deploy or instantiate both containers, TensorFlow and PyTorch, and also virtual machines. In this particular video, we're just going to focus on the virtual machine creation. We'll break it up into different pieces, showing you the instantiation of containers in another video, in the next video. But let's just focus today on just the virtual machine creation. So we have a few machine cloud native images. We have CentOS, Rocky Linux, Ubuntu, and Windows 11, which will show you how to deploy. And we're utilizing the KubeVirt plugin for this. So this is gives us the ability to instantiate these VMs and be able to log in. And we'll go in and we'll basically validate whether these images can communicate with our top of rack switch out to the internet. Maybe we'll Google browse something, as far as what's happening in the world out there, and then also show you how we can use a yum update and also an apt-get update within the environment to show you that we have full functionality. And this is truly a cloud GPU as a service or cloud virtual machine environment, which is on-prem. So enough of my babbling. So let's start. We're going to navigate to the landing page here of 172.24.168.108. This is the port 3266. We're in the landing page. So this is our control plane. Remember, this was the virtual machine we created, which was hosted by a CentOS 10 hypervisor. And we went into and showing you how to create the virtual machine, which is this control plane through Cockpit, right, in previous videos. So let's log in here. So we're going to sign in here, and we're going to use the culpk account and our password. And don't forget to use the drop-down LDAP. So this is the user we created through the admin account. One of the things I do want to point out to you is that the admin account does not have the privilege to instantiate container images nor virtual machines. So that is an account you set up, whether it's project-based. Many of the scientific environments and running different inferencing models and prototyping machine language have to do with projects. Maybe universities have these projects where they house or share out a specific GPU, right? And as a service, right? So it kind of goes back to the old days when we used to do mainframe sharing, time sharing, right? So I guess I'm showing my age a little bit here, but in the IBM 4631 days on mainframes, we used to do time sharing, right, of various different batches that were run within a data center because these machines were so expensive. Was something we had to do back then. And so we're kind of, there's this essentially kind of in IT, this life cycle management wheel that continues to go on and around. And we just have a different look and feel of how we present something. So in my journey, and I've been very blessed to see the evolution of going from punch cards basically into what we are today, of having, of being able to instantiate virtual machines through Kubernetes. So I've been blessed, and it's been a great journey for me, and I'm excited to show you what we are cooking here at Supermicro for entire software stack. So, anyways, I'll stop my babbling here and rambling on, and let's log into our environment. And we come into our environment here, and you'll see here a little bit different information that you would have saw in the admin account. So let's log into the admin account and just show you here anyways. So let's cut and paste this in here. And let's come into the landing page and be able to log in, log out of here, culp here, and come in as our admin account. All right, so we're coming in an admin, and you see here we have different information. We have hosts that are operational, right? We have 3 nodes or 3 hosts within here, a GPU server, and then which are basically workers, 2 workers, and then a master, which is essentially the master control plane that's basically forming our cluster here. Anyways, let's go ahead here and navigate back here to our environment we logged in under as culp K here. And this is something we set up. Remember, we went through the import function here with under settings here to set up our user management here. And this is showing you a number of accounts that we have set up. And remember, we went in and used the import function here to import from our domain controller that exists within our demo center. So we're actually looking at another particular control plane that we stood up here. Remember, these control planes are been instantiated or created as virtual machines through CentOS 10. We had the cockpit, remember, that we created these virtual machines. So we have layers of different technology coming into this environment to help you understand how you would deploy a GPU as a service, tenant cloud, or virtual machines of sharing out this environment as an on-prem cloud environment. And I wanted to also mention here is that remember in the previous videos we talked about deploying north, south, east, and west shards. Why we're not talking about that today is because we're continuing to build in our GPU tenant cloud. We ran out of power utilization in our location because now we're housing very large GPU servers, which were requiring lots of power, and thermal and PU became a burden for us and a challenge. So we got the opportunity to move our entire lab over to a new location, which is we're going to provide customers to look at our liquid cooled lab for direct to chip and liquid immersion, and what we're building in SuperCloud Composer from a data center operator level, and then basically giving you the opportunity to experience what a real GPU as a service tenant cloud is, and having the available footprint floor size for us to put a number of racks in there. So we're really blessed here, Supermicro, to have the floor space and hardware to be able to help you evaluate our products and see where we're moving from a complete vertically integrated software solution. All right. So enough of the babbling here and rambling. So let's go back into our environment here, and we're going to choose the virtual machine option. And so we're going to create a number of VMs here. And the first thing we're going to do, let's create a Windows VM, and we're going to give it 8 core, 16 GB of memory. These were created as flavors, right, under a system admin account. So now they show up as valuable recipes for us to deploy our cloud native images against. So we're going to use the 8-core 16 GB memory. We're going to create our golden image, and we're going to use Windows 11 as our cloud native image here. And we're just going to go up one level, which is 60 gig. So I recommend you utilize the same size, 59 GB, or maybe bump it up a gig or so, just so that you have some breathing room so the cloud native image is successfully deployed. And we're using our NFS storage pool backend. We created this. We created these environments. Remember in the previous video where we deployed our backhaul storage for NFS as a server storage through a large storage server that we deployed, and we made those disks available within the developer consoles themselves. And we're using that as backhaul storage to store our images. And we also created here a bridged interface that allows us to get out into the internet. So if we didn't create a bridge interface, none of our virtual machine endpoints would communicate to the real world, sort of our top of rack switch. So we have to have that relationship there under Kubernetes. And if you're familiar with the concept of KVM hypervisors or say VMware, you have this vPort to VNIC relationship, and that gives you the ability for those virtual machines to communicate out to the switch switch network, right, or to your internet. Then we'll also create our CulpK access account that we're going to log in, and then we're going to put in our password here. And then we're going to come down to the end and submit, and then it will basically instantiate our virtual machine, which is Windows. So let's create another one. We're going to create all 4 of them. So we have CentOS, Ubuntu, and other ones. So let's do our next one here of our, let's do an Ubuntu host. In this case, we're going to use 4 gig, 8 GB memory for our flavor. We're going to create our golden image, and our golden image is going to be Ubuntu 2204. It is selecting the data storage of NFS storage as the pool we're using. And then we're going to use a 10 GB space here to deploy against as the size of our virtual machine image. We're going to use the bridge interface here to communicate out to the rest of the world and our internet. And we're going to plug in our password here for the CulpK account. And then we're going to hit submit. And this will provision the next host here, which is basically our Ubuntu host, our virtual machine. So you're probably saying, well, where are these endpoints being created? Let's go and take a look at that. So if you go in and look at under the networking portion, which is here, we come down here under networking, find the option here. Where is my networking here? Am I logged in to the admin account? Yes. So we have our cluster services here, and then our networking. Networking is here. And we've created this bridge. We've added a network here. And we've so far used 2 IPs, and we have 3 available IPs left from our pool, right? So these are basically IP addresses not to use, right? That they've been reserved within our environment, right? So we went in and reserved our pool. So in a real cloud environment, you would have a range of IP addresses that are potentially reserved, that are static addresses that you would not use, right? So you would just create your network here and then come in here. And if you're running any VLAN tagging or gateway information, you would pass that information here within the ad network piece. So that's how we're getting the B6 Building 6 network bridge to tap into. All right. So back to our virtual machines. Remember, you cannot create VMs into the admin account. You have to create VMs, virtual machines on your account that is capable that you've assigned, maybe perhaps to a project, or also that you've given it the ability to create these virtual machines through your privilege and credentials. All right. So back to virtual machines here. We already have one running. So let's go here and come back to our culp K and create our VM here. And by the way, you notice here, there's no option here on the top on the right-hand side to say create a VM, right? So that will tell you, give you a clue that you're in the admin account, right? So there's no label provided. Of course, here you can see here we're logged in to admin as well. So here you're given this label. And so we've done Ubuntu and Windows. So what do we want to do? Let's do CentOS, right? CentOS compute. We're going to, again, let's use 18 core, 16 gig as a flavor. We'll create our CentOS image here. We'll put it as 15 GB. Again, we'll connect into the bridge and use our culp K account and put in our password here. And submit. All right, so that's instantiating and provisioning. So next, we'll create the next one here. Let's do Rocky Linux is the next one. Okay, so we'll call it Rocky Compute. We'll use 4 core, 8 GB memory. We'll create the storage. Storage image is Rocky. And we're going to use 15 GB again here. We'll connect into the bridge network, culp K, and the password. And submit. All right. So these are provisioning, and they're basically being instantiated within our cloud environment here. So I'll let this continue to provision and deploy. And that completes this video clip. Thanks for joining today. You have a great day, and we'll see you across the aisle.